Bonjour y'all, Adrian Lambert here, welcome back on my channel. Today we're gonna have a deep dive into USD and Solaris. So if you have no idea why you should consider using Universal Scene Description, maybe have a look at my previous video. You'll get some history and broad explanation about that. It's maybe good to see because from now things gonna get technical. We are talking here about an approach that can support pipeline for major VFX and animation studios. So as you can imagine, learning this approach can be a bit intimidating. It's far to be an intuitive thing to learn. I don't want to scare you, of course. I'm here going to try my best, okay, to share my understanding, because I truly believe that great pictures are made with great teamwork, and USD in that way is the most collaborative approach I've ever seen in my career. Of course, I'm still very much learning myself, so please don't take my words at face value. Maybe double check with a glossary from Pixar or Side Effects and make your own kind of understanding of the different concepts. In this video, I'll try to introduce you some of the USD lingo, and we'll see how Houdini Solaris is using its nodal approach to wrap the USD concept around a category of nodes called LOPs. So without further ado, let's get started. Alright, so it's time to talk about Solaris. So if you have never used this approach before, I'm gonna recap a few basic stuff about it. First thing you wanna know, of course, is the UI, where you can actually set it up to Solaris. From there, it should at least open the two most important panels, which are the scene graph tree and the stage context. So the stage context can be found in here. This context has been implemented as an alpha version since Houdini 18, but I strongly recommend to use it, at least in Houdini 19, because a lot of work has been done on it since, and it is now much more production ready. The stage is where we drop the LOP node, and on the left side is where we get the USD representation of the scene. So what's happening is the node in stage doesn't really control the viewport like in SOP. It controls the scene graph, and the scene graph controls the viewport. In any software that supports USD, you should see a similar panel than this graph. To illustrate what's happening, we'll just use a subcreate. Subcreate is a very useful node because it allows you to do anything that you would usually do in SOP in Houdini inside the LOP context. It's kind of like a subnetwork where when you dive inside, you have this representation and you can do your thing, right? So let's say we want to add a test geometry like Crag. Let's put this guy. So we have Crag, and let's go back to stage. Test geometry is properly loading. Well, except the material or color. So that's something that probably would need to be dealt with differently in LOP to make it work. We will do that later. What I want to show you, we should have this subcreate one right here, which is called the primitive. So according to Pixar's USD glossary, a prim is the primary container object in USD. The prims can contain other prims, creating a namespace hierarchy on a stage, and prims can also contain properties that hold meaningful data. For example, these transforms are primitives, and they are contained within the subcreate primitives. Let's do a test and bring a prune LOP. So this prune would allow you to control the visibility property of some primitives. So this expression right here in the primitive pattern would target the first imported input, but you have different things that you can use. Of course, if you want to prune, you can use a bounding box. You can use, you can also prune by type, kind, etc. So that's something that we can use later on. But in the meantime, you can also specifically drag and drop some primitive path, like this chest, and it's getting rid of some chest piece. So as you can see, we have this big chunk missing now. And we can, of course, do a selection and drag and drop that in primitive pattern to get rid of a few things. So when it comes to primitive and subcreate, you may, in most cases, want to load that as a reference. What Houdini's help is telling us is that with USD you have two ways of importing the content of another USD and subfile. They might look very similar, but the first one is sublayering the tree of the imported file over the current tree, while the other one is called referencing. It basically attaches the content of the imported tree as a branch on the existing tree. You can think of sublayering as composing a different version of an asset or a scene, while referencing is adding a new part to the scene. For example, adding a new props to begin a layout. Whether this is on or off in the context of a subcreate, you won't notice much difference. Before we create this geometry, we had this empty subcreate, which is just an X form, as you can see. But because in this test geometry, we have an attribute called name, what it's doing is that it's taking all the geometries that have this name actually set and pull it under this subcreate. So the hierarchy in this case is controlled by the name attribute. Now let's say we have something that doesn't have a name attribute, like a sphere. All right, we'll set that to polygon for now. Okay, and what you can notice is that we have this mesh 0. So in most cases, when you're dropping an object that doesn't have any name or path attribute, it would just call it mesh 0. And if you want to customize the name, you can always drop an attribute create. Like so, let's set that to primitive. We'll call this guy name. And I insist it has to be called name, not name1, name. And we'll set that to a string because it's a text, and we'll call that sphere, for example. And as you can see, it's updating the name right here because it's basing the naming on the hierarchy of our objects. And if we are trying to change the hierarchy into something more complex, like high-res sphere, it's creating a next form under the subcreate, and that contains this sphere. So that's pretty handy. And note that there is another attribute called path that would actually do the same thing. The path attribute is pretty universal and is also often linked to the Alembic format. Let's say you are in Maya and you've been working on an asset, got it all clean with a tidy hierarchy, and you're exporting that as an Alembic. The different geometries contained in your hierarchy would be translated into a path attribute. This path attribute would be represented as a long string with slash to indicate the different parents composing the structure of your hierarchy. And all of this would be represented properly within this scene graph. So yeah, load as reference. When this is off, you are sublayering, basically overwriting the hierarchy. When this is on, you are adding to the hierarchy. But also you take advantage of what's called a payload. And we notice actually in the graph that the primitive is turning orange, which is the convention here to show what is being loaded as a payload. So one trick is that you have this show legend right here that would basically indicate what's happening. Like if you are looking to a specific color, this orange is indicating that we have a loaded payload. So notion of payload is something pretty new as well, I assume, if you are not familiar with USD. Fortunately, we have side effects USD glossary that can help us with that. They define the payload as a special kind of reference that can be unloaded for optimization. So what's interesting is that when files are combined with payloads, it is easy to control which part of the scene are loaded into memory, keeping memory use and processing time down by letting you load and focus on those parts of the scene in which you are interested. If you are familiar with Katana, it's basically the same principle where you just load whatever you need. By default, Houdini loads all the payload, so something to note, but you can use something like a configure stage lop to actually control that. A payload can be weaker and another can be stronger, just to actually facilitate some things in terms of display. We'll talk about that later because it's mostly interesting when we have huge scene. Right now, it's hardly the case. But yeah, note that most cases you would want to load things as reference to optimize the memory. And right now, the primitive path is set by the name, which is called subcreate. And it is defined by this $OS, which is calling this node name. You can always manually edit it and say, I want to call that my LOP. And here you go, you have my LOP with iRes, etc. So we'll call that my object, I don't know. And one thing to be aware of is that this primitive, you can always edit it using a configure primitive. Configure primitive. And what's interesting with this node, you have basically some ways where you can change the type of a primitive to certain other things. Like, let's say if it's a mesh, it's gonna change the type to a mesh, and later on you can filter any primitive by primitive type, etc. So that's an interesting tool to have. And there's another thing within this configure primitive that we're gonna try right now, which is the purpose. The purpose in USD basically define what representation you want to use based on if you are rendering or visualizing the scene in OpenGL or using guides for simulation, hair, or whatever. So default would store the default representation in any of these states right here, which means right now if you try to visualize any of this, the sphere looks all the same. But we could configure it in different ways based on those different setups. So if we would say, I want to see the preview, well, in that case, we could set up a purpose for the proxy. So the proxy in this case means a low-res representation of an object. So what we could do is go back to this subcreate and we'll define a low-res geometry. We'll just drop a polyreduce and basically decimate this guy to 7%. We'll copy this attribute create, and in the string we'll basically say this is a proxy. And actually, to make that more clear, what I'll do is that I will call that render. So what we'll say is specify when we want to use this for render and this one as a proxy. We'll just merge those two guys. And about merge, I will need also to talk to you about that in LOP because it's a bit different. So right now, those sub are merged properly, but we want to configure the display. So what we'll do, we'll just drop this sphere into the primitive path. And we'll explicitly say the purpose is for the proxy only. While if we are dropping the high-res one, we would want to set the purpose to render. Now, what's happening is that when I set that to final render, we are only visualizing the final render. When we are turning that to preview, it's only showing the proxy. So that's actually a pretty interesting mode to have. And when we try to actually set a render, let's say with Karma, it should use always the render geometry. So right now it's just a stupid sphere, so there's no real benefits to that. Once we start using that on heavy scene, like environment with a lot of instances and so on, that will be super useful. So for now, I promised I would talk to you about merge. So let's see how it differs from SUP. I'm gonna drop a transform. Let's say I want to clone this object and have it someplace else. Right now the primitive isn't moving because this expression is set to pick up the first primitive found in stage. Since our asset structure is much more complex, it's confusing Houdini. In this case, I would rather use an asterisk, and let's not forget to add a slash before to clearly specify we want to move the primitives contained inside the stage, not the stage itself. Now, what's interesting is that if we try to merge those two guys, let's see what happens. We actually don't get those two spheres like you would expect in SUP, you know? And the reason is because the primitive is exactly called the same way it's not merging things, it's basically sublayering a new position of these objects. So it's like if this object all of a sudden got overridden by this new one right here. So if you would actually want to display two different spheres, in this case you would need to rename this guy. One way to rename it easily would be to use a stage manager. And in a stage manager, you see a representation of your graph. And you can actually edit things, you can move things from the folder, etc. So I wouldn't recommend to mess up the hierarchy in this case, but just changing the name to, I don't know, my object B in this case would allow us to get two different spheres. Because now we have an object with a object B structure and one with just my object. So yeah, that's just something to keep in mind when it comes to dealing with USD. If you actually already have some object in SUP, like, I don't know, let's bring Craig again. Let's say we want to bring this guy over. One note that might be useful is the SUP import. So SUP import, we would basically use this button to load any geometry that we would want. And yeah, now we got this guy. And same thing, we would want to load it as a reference and everything would work normally. But what if we have some instances system? Let's say you have something already set up with some instances. So I will just scatter some stuff real quick. Okay, we have this. We'll drop a sphere and a copy to point. We'll just do some simple polygon sphere and something like that. Okay. So let's say we want to bring this geometry. We'll call that scatter. Let's see what we get. So the first thing is that it's actually in a big mesh right now because we haven't packed the copies. So that's not actually the most optimized way to work. So let's go back in there and set that to pack an instance. So interestingly, now we have several nulls containing what is called an instance proxy. That's what this blue color means. Look at that, plenty of those. And this instance is based on what is called a prototype, which corresponds to the source geometry. So I'll talk about that later when we'll be dealing with the LOP instancer. And talking about instancer, there are different ways you can import these packed geometries. You have the create native instances. You have also what is called a point instancer. In that way, what it's doing is that it's just grabbing this prototype and copying things over point, which might be much more optimized if you have a lot of points and that you need to bring them into stage. So yeah, something to keep in mind. In that case, I can, I don't know, have much smaller sphere and put, I don't know, this amount, and it shouldn't affect actually what's happening in stage. Well, if I'm doing create native instances though, we are having a huge hierarchy and actually that might affect the performances. And of course, if you try create xform, it's killing the instancing and just having a mesh per null, which is pretty useless in that case. And unpack, well, that's just the same mesh, but without nulls. So point instancer is actually a good way to bring some packed geometry within your system, especially if you have particle simulation, for example. All right, there are a few more things I need to talk about, and one of these is the concept of variant. So in USD, you can store a variant for a model or a look dev into the same USD, which has a lot of benefits down the line. Let's say if you want to change the look of a car within your shot or something like that. So the way to do that, we'll import Krag as an example. Let's bring this dude over and we'll load it as reference. Make sure that we give it a proper name to the primitive, because right now it's just sub import. So we'll call that Krag. And now that we have this dude, let's add what is called a variant block. So let's do add variants to existing primitives. So we have this block that's showing up. And basically you have this input for the input stage. And this is for what we want to copy into the variant. So we'll just grab the same input right here. Actually, I will drop a null just to make sure that we have some room to do modification in there. So yeah, what's happening in here, if we look at this panel, first we need to define a primitive path where we want to store the variant. Right now it is basically within this variant block n that appeared. What we'll do is define this primitive path to Krag. And now you see that in variants, we have that onto the Krag primitive. So yeah, you have just to be cautious about that. And one thing, since we need to make things a bit cleaner, we'll drop all this hierarchy within another hierarchy called geo. To do that, we'll just do something like geo. And yeah, basically we could store the variant specifically on this one actually. And if we have a place for the materials later, we can assign a variant right just for the materials. So what I like to do then is to do something like Krag geo. Now the variants are starting to get applied to this guy. So one thing to be aware is the name of the variant itself. Right now it is a variant set called model. So that would be any changes related to the model. You could call that whatever, of course. I don't know, var. I would just leave it to model. I'm happy with that. So what's happening, the variant name default would be based on the input. And what I usually like to do is to use a null to define the name of this variant. Right now you see that it's basically changed to null too, because thanks to this expression, it's picking up the name of the first connected input, which is in this case null2. But we'll call that varb. For this variant, let's say I want to prune some geometry. So we could drag a prune. And in this prune, we will want to get rid of a few things. Let's say we want to get rid of the head and the chest. I don't know, just random example. So yeah, let's also get rid of... So let's say for some reason we want to do something like that. Well, what's happening in here? We are having this varb defined in the variants. Now, the thing is, we have this set variant selection, which is enable, which will just set the current state to the variant we created. And there can be many of those. We could totally decide to create several of stuff. Let's say, I don't know, getting rid of these pieces. So that would be another variant, for example. We'll call that var C. And you can plug as many as you need. And as you can see, it's just picking up the latest variant that it finds. So one way to actually control which variant to display, there is a LOP node called setVariant. And also one thing I forgot, I will just use this null to set that as var A, for example, which is the original geometry. So what's happening in variant set, we can use this model, and basically in there we should find the different variant that we created, and we can set that to B, C, or no variance, which is the default one. You can also right click and decide to switch the representation to var B or var C, etc. Now this example kind of showed us some weird limitation actually. If you notice in prune, if you try to select a specific primitive, you can only select the whole Crag model. And maybe we would want to, for this variant, be able to select the different component of this guy. To do that, one thing to know is within your primitive, you have a property called the kind that actually defines a role within your different primitives. You can see that in the graph here. And because there is no role assigned to our different primitive, we are not able to select them straight in viewport. The graph so far actually consider our geo primitive as one big component, and anything below is just not worthy to be selected. But we could change that. I know the kind is usually a blocker to understand though for most people, so let me pull side effects documentation for some extra clarification real quick. And okay, it actually provides a helpful example in this case that describes the different kind that you have. Like a kitchen would be an assembly, the dining table would be a group, the chair would be a component, and the chair cushion would be a subcomponent. So that's what it's all about. It's helping you to define some role within your hierarchy and facilitate the assembly of your scene. So there are a few ways we could proceed to define the kind. One of those, well, would be to leverage the sub import, and there is a section for that in primitive definition, I think. If you go in kind authoring, you have all the geometry is one component. So let's have a look at that. Basically, it's not changing much. If you set that to none, well, there's nothing is defined. And nested groups and component. What it's doing is anytime it finds a X form, it's gonna apply a group. And when it finds a geometry, it's gonna turn that into a component, which might be what we are looking for in this case. Otherwise, you have nested assembly, groups, and component. In that case, it would add another level of hierarchy, which is the assembly. So now we have this geo, we have group and component. In that case, I'm happy to leave that as nested groups and component. And now what's interesting is if we go inside one of these prunes, we should be able to select the components of our model. It's if we want to get rid of this hammer, we can just get rid of it this way. In here, I don't know, for some reason, we want to remove all these legs. We can totally do that. And yeah, thanks to a bit of reorganization, we are able to manipulate the variant much more easily. So of course, there would be another way if you are not actually using a sub import, but for some reason you still need to change some specific kind on those primitive. You could just drop a configure primitive. So we talked a little bit about this one, and basically you would just need to drop what primitive you need to change. And we talk about this configure primitive when talking about purpose, but you also can affect the kind, and you can set any role that you like for this specific guy. So in that case, my abdomen mid is becoming a component, not a group. You can of course use relative path if you have several primitives to change. You could basically drop this and you could put this symbol to affect all the content. Now everything is a component. So this concept is pretty important to understand, but keep in mind that in most pipeline, if it's well done, it should actually take care of it under the hood. Now it's time to talk about materials, because I don't know if you remember, but that guy right here was coming with some materials. If I go back in OBJ, we had this geometry that contains this dude with a few materials for the hammer and for the body. So what we'll do is go back to stage and we'll create a lab called material library. So this node is extremely useful because it allows you to create material or bring some from other context. So if I'm checking out in here, I can browse through the OBJ directory and we will find a matnet that contains a few different shaders. So we have hammer paint and principal shader. We'll bring this guy over, and what's happening is inside your graph you should have a materials that have been added with this principal shader. So that's pretty cool. Now you just need to assign it. You have a way to assign it through this node directly and basically specify the primitive that you want to apply. And as you can see, it's applying on everything. If you want to actually assign a material later, you can use an assign material. And this node, basically, you would specify the primitive and the material you want to connect. So for now, we'll just use the material library itself. And let's say we want to bring the other material for the hammer. In that case, we'll just bring this hammer paint and we'll find the geometry that corresponds to this specific one. Just like that. And now we have this shader assigned. So that's a bit better. And one more thing I would like to do. Basically, the material scope is living under the stage, but maybe I want to put it right under this crag primitive. So that's easy enough. Just at the material path prefix, we can just specify crag. And now it's just below this guy. So when we save this primitive, it should also store the materials. So now let's say we want to create a custom material and apply it to a specific primitive. So to do that, we can just dive inside the material library and create any material. The material we've been importing are principal shaders, which are fine with Houdini, but might not work in other applications. Material X would be a standard way to share materials across package. So I would rather encourage you to use that. But well, for now, since we are just staying in Houdini, we'll just use our good old principal shader. So we'll talk about Material X in the next video when we talk about Megascan. That should be pretty interesting. For now, let's just use this guy. We'll just assign a metallic color and yeah, let's just try that actually. I will call that metal. And we'll create a new spot for it. So one way to actually retrieve this guy, because it's actually living in stage, we could just drop a star like that, and hopefully it should bring the metal material under the material scope. So that's all good. So now maybe we just want to specify the material we want to use, which will be metal, and we'll assign that to something like this head. So it's not working because I guess we kind of have some issues right here with the name. So that's pretty much it for the material library. All right, one last important thing to talk about, which is how to export a model into USD. With it comes a concept called layering, which I'm gonna try to start explaining. If we want to export, there is a LOP called USD ROP. This would be the main node if you want to export anything into USD. And all you need is to define a path and .usd. What we'll do is call that crag asset, and we'll store that into a directory called asset. So if you actually try and save to disk now, it wouldn't work, mostly because what's happening is that Houdini is looking for some layers. So in this panel, the scene graph layers, it's a representation of all the different layers in your scene. So crag is one layer, but potentially if we add something else, that would be another one. For example, I'm gonna merge one of our previous SUP import. Let's say this scatter. This scatter corresponds to another layer. So hopefully that makes sense. And the thing is, all these layers need to be saved at some point. So this implicit basically means that it will be saved based on the directory of this final USD. So the save path is not actually set. So why it's erroring is because by default, the USD ROP has this option, error saving layers with implicit path. mostly because it's usually cleaner to have a proper control over what layers you want to export, if you need to export them in different directories, etc., for the need of your pipeline. So if I'm disabling that, we should be able to export those layers properly, but at the same time, it's gonna potentially save things into weird places. So we can try that. And if we look at the result, well, it did export an asset.usd, but also this obj folder that it created automatically. And yeah, it basically saved the SOP version of Krag into this destination. So to import this exported model, there are several ways you could proceed. One of them would be to use a reference LOP. And in reference file, you would pick this Krag asset.usd, the main one that was defined in the ROP. And yeah, that should work as it is. Just note that the name of the primitive would be based on the node name in this case, because we need to check that primitive path, and I'm called that explicitly Krag. I don't know how it's pronounced. And yeah, that seems to be about right. If we try to actually change the model variant, it should technically work. It's automatically adding this set variant, so that's great. And it seems like everything's exported properly. So we also have the materials that comes with it. So that's great. So this step right here would correspond to publishing an asset. And in a brand new scene, maybe layout would actually pick up this guy and place it in the shot. That's good to know, but what is this concept with these layers and thing? So the implicit is something we saw we can still save no matter what, but at the same time, the cleaner way to go would be to actually leverage this layer save path. So if I'm check this on, I can specify a destination where I want this specific SOP to be saved. $heap, there was this folder asset, and the name, we'll call that, for example, kragsop.usd. So if I'm looking now in here, we see that there is a path that has been added in save path, because before it was not set. So which means it was implicit and that it would be handled during the export. And we could also save this layer, because what's happening with this SOP import is that it's storing a SOP layer, but there's also the main LOP layer that you would need to save. And to do so, if you, let's say, need to save the LOP with the proper materials, well, in that case, you would need a configure layer. So this node is pretty important to actually export some USD layers, and you would need to save the path as well in here. So we'll just pick up the same naming. I will just call that Krag LOP, for example. I don't know. And as you can see, it changed the save path and set this save control to explicit now. So yeah, that's one thing to take in account. And I think in general, you would want to define a default primitive. Default primitive, well, that would be Krag, for example. And yeah, I think you could also define the up axis. Depending on the app, it would automatically pick up the right orientation based on this. There is also a start and time if you have any specific animation you need to save. You can add a comment, etc. So that's pretty useful to keep track of the different USD that are being saved. Anyway, at this point, if I'm going back in this USD ROP and turn on again error saving layers with implicit path, in theory right now it should work properly because everything is explicitly declared. So let's save to disk. And in theory, yeah, we have this KragLOP USD and KragSOP USD that have been created. So if I'm going back to this reference, in theory, there shouldn't be any visible changes, but it's just in terms of organization, how you are dealing with your USD that does make a difference. So yeah, that's something that I wanted to flag to you, and basically we'll talk more about layers in the future videos, but it's actually super useful because if another department now need to adjust the position or anything with this particular asset, well, you can save a new layer that will store some changes, but we'll talk about this later. To finish, I will just show you one more way to actually load a reference, and that would be using the stage manager. So we saw in the past that we could use it to manipulate the hierarchy within our graph, but we can also use it to load some reference just by clicking here, open file browser, and you can see I have this asset thing, and I can drag and drop any USD from any location. And then if I'm looking at this guy, well, we are having this crag. So once I'm happy, can remove that. And of course you can duplicate this primitive just like so, or with Control D. And you can also, well, move it in space. And of course you can change the variant of this guy. So if I'm doing edit variant, so in theory you should find them in here. It's just because I actually set my variant within the sub-hierarchy in Geo. I would just need to change the variant from here, model varb. And in this case, it's actually dropping a set variant for this one. So Stage Manager is one way to manipulate the layout of USDs, but we'll see that in Houdini 19, there are more than a way to actually handle that. And that's pretty much it for today. Thank you so much for watching. I hope all this information wasn't too overwhelming. If it was, don't worry, everything will make sense pretty soon, hopefully. In the next video, we should be in good place to start converting some Megascan assets into USD with Material X. We can then build a library of assets to help the assembly of our 3D scene. So stay tuned if you don't want to miss that. Thank you for watching, take care, and I'll see you guys next time.